Hi, as promised, here's another rigging vid. This time on using matrices as constraints. Here we've got an IK handle and we want to constrain it to an IK control. We start off by creating a matrix node and we take the world matrix of the constraining object, in this case the IK control, and plug that into the matrix import. All of its transform values are held in an array, but we need them separating into their respective channels. For this, we use a decomposed matrix. All we need to do is connect its output into the input matrix, giving us outputs for translate, rotate, and scale. More often than not, a constrained object is itself a child, in this case the IK's group. When you use a typical constraint, in the background Maya works out the difference between its world and its local space values. Using matrices as constraints, we need to take that into account for ourselves. So we take the world inverse of the parent of the constraint and plug that into the matrix as well. And now all we have to do is connect up these and we're done. That's all well and good, but what if we need to maintain an offset? As before, we need a matrix and a decomposed matrix. Now if we connect these up exactly as we did before, the cube will lose its offset. First we need to calculate the offset, so we need another matrix. Pipe the world matrix of the object to be constrained, the cube, along with the inverse matrix of the constraining object, the sphere, in this case. The output of this matrix is our offset, and it has to go into port 0. Maybe it's the way matrices are calculated, but if it goes into any other port, it doesn't always maintain its true offset. Now we can't pipe it in directly because we'll get cycle error, so we need a couple of lines of code. Run it, copy the values. Before I run it, I'm just going to move the world matrix into port 1. Now I can run this line of code and we have our offset. We also need to pipe in the offset of the cube's group. Connect it all up, and now we have a constraint with offset maintained. So that's all well and good, but what if we want to blend between two constraining objects and maintain the offset? Okay, so this time we're going to constrain the cube to both spheres and blend between these constraints driven by the translate x of this control. Because in this example we want to maintain the offset between both spheres, I've gone ahead and got the offset values for both. Each constraining object, sphere in this case, needs its own matrix node, and I've piped in both their corresponding world matrix and offset values. I've also changed my screen capture software, so I'm hoping the quality is a little better. So, in order to blend between the two, we need a weight matrix. Pretty straightforward. You're not limited by the amount of inputs, and each one has a weight input, which means they're not normalized in the same way, say, a blend color node is. Once we've connected the matrices, now we need to control the weight of each constraint. I'm going to use the translate x of this follow control, which I've already limited to a range of between 0 and 1. I'll pipe this into the input weight of the first one. As the constraint weight has been added to sphere 1, obviously I want to take it from sphere 2 And the easiest way to do that is with a reverse node, which I'm sure you're already aware does exactly what it says on the tin. So the translate x values of my control go into input x, and its output x will now drive the constraint weight of sphere 2. Just so we can see the outputs of these weight matrix, I'm going to add a couple of attributes. So now if we have a look, we can see the weight matrix now blends between the two. Now we can connect it to another matrix, which also has the input from the parent's inverse matrix. So I'm just going to get a better view. If the cube shifts, then we know I've made a mistake somewhere. Just making a final check. Okay guys, keep your fingers crossed. Right, well we've finished in the node editor. So at the moment nothing is happening, and as both spheres are in their default position, this means that both constraints are maintaining the offset, which is good. But as I move the spheres around, the cube blends between the two, depending on the weight value, and keeps its offset. It also scales, and it rotates. Anyway, I hope this has been useful, and if there's any particular area of rigging you want me to go over, just let me know. Although I should point out that I'm not the Colin Harvey of rigging in Maya, sadly. Anyway, take care. Bye.